Okay, so we have another Khan Academy exercise here, and we need to talk about what it means to add and subtract radicals. So, a radical is something that, we call some of these numbers, they're called irrational numbers. And there's a reason why. So let's take a screenshot here, and we can write about this for a little bit, okay? We can take a look at it. And I think what we'll do to kind of really explore this a little bit is, I think what we're going to do is we're going to do a little bit of, we're going to use the CHS first just to kind of see the answer, and then we'll talk about why that is. So I see that it's root 45 plus root 5, and I need to come up with an answer. So I'm going to go to Khan Academy. I'm going to put the square root of 45, so here's the square root sign, right? Control x squared, and there's the blue, you can see it, the square root sign. So the square root of 45, right? I go to the right because I don't want my plus sign, I don't want the plus sign to be underneath this, what we call the radical, right? So I'm taking it outside of the radical, and I'm going to take the square root of 5, and I want to find out what the answer is. And it tells me the answer is 4 root 5. So why would that be? Well, we're going to talk about why that would be. So the answer, we know that this answer is going to be, we know, the calculator's told us this is going to be 4 root 5. Well, I want you to think about when we add terms that are not fully defined, we can't combine them. We don't combine terms unless they are like terms. We combine like terms only, right? And thinking about, what you learned in pre-algebra, if I had 2x and I add 3 more x to it, I can get 5 total x's. But I can't take 2 x's and add 3 y's and come up with 5xy. That's not going to work. I can't combine them. In fact, I can't take 2x squared and add 3x to it, because not only does the base have to match in the variable, but the power has to match as well. The exponent has to match as well. And so I can't combine these. That's as simplified as that can be. Okay? I cannot combine them. You can only combine like terms. So combine like terms only. Well, these are irrational numbers. The square root of 5 is what we call irrational. It cannot be, what that means is it cannot be expressed as a ratio, right? It cannot be expressed as a ratio. And when we say a ratio, we mean a fraction, okay, with actual integers in the numerator and in the denominator. Integers on top and on bottom. So the only way for me to express what is the square root of 5 is for me to write it as the square root of 5 over 1, or 2 times the square root of 5 over 2. And that's the only way I can write it as a fraction, because I can't put it as an integer over an integer. So we call this an irrational number. So what happens is, how do we add the value of something that cannot be expressed, because it's irrational? Just like we can't add here, we have to have like terms. So clearly we did add them. And you can see this, and the calculator did add them. So how was it the calculator did that? What was it the calculator did? Well, it must have reimagined this root 45 to be an irrational that was a like term with root 5. And I see that root 5 is in my answer and that I have 4 of them. So if this is 1 root 5, then root 45 must be equal to 3 root 5. That's the only, 3 root 5. That's the only way that I could get to. Let's think about 4 root 5 being equal to 1 root 5, right? That's what root 5 is. There's just one of them. Being added to something, it had to be 3 root 5. So now the big question is, how does the square root of 45 equal 3 root 5? Why would that be? Well, let's look at the properties of 45. 45 is also equal to 9 times 5. And if I wrote it as the square root of 9 times 5, what happens is, because of this power of factoring that I just did, I could say it's equal to the square root of 9 times the square root of 5. So in this case, the square root of 9 is a perfect square. And the square root of 9 is 3. So this is equal to 3 root 5. So that's how we got this answer. We looked at this and we recognized there's a perfect square inside of here as a factor. And we factored out this perfect square, root 5. Then we took this perfect square, we square rooted it, right, and turned it into 3. We square rooted a perfect square and turned it back into 3. Now we have 3 root 5s, and we added in 1 root 5, even though it just says root 5. We can always write a 1 in front of it to think about it as 1 root 5, and together we get 4 root 5. Okay? So, let's go back to Khan Academy here. Oh, sorry. So this is equal to 4 root 5. So, what happens when we want to add and subtract radicals? Well, in order to subtract them, I've got to find a way to think about these two being like terms. And the like terms here, can I simplify either of these to get them to be like? And I look for my factors, right? Is there a way that I can break this down, or is there a common factor of 54 and 6, right? So what is the greatest common factor of 54 and 6? I might try doing that on my calculator. Remember, let's see, I think it's called the greatest common factor. Is that right? No. Greatest common multiple? No. Oh, I forgot the command, right? Was it least common multiple of 54 and 6? That would, no, that's the, oh, greatest common divisor of 54 and 6. Sorry, that's what we're doing. I forget sometimes, and especially when I'm talking on the fly like this, but we're looking for the common divisor, the greatest common divisor. The way I can, the least common divisor here would be 1, and 2, you could divide both of these by 2 because they're both even numbers, but the greatest common divisor is 6. So I know I can divide this by 6, so now 54 divided by 6, what would that be? Well, that's 9. So I know that this can be written as 9 times 6, right? Okay, so you can use your calculator to help you figure that out, but I know that, let me take a little shot here. If I just want to write that out, and I'm going to, let's see, put that in a fresh page so we can kind of work on it. Okay, and I'm going to kind of blow that up bigger. So here we have, ooh, that's out of focus, but you'll get the idea. The square root of 54 can be rewritten as the square root of 9 times 6, which can be written as the square root of 9 times the square root of 6, which is 3 root 6. So 3 root 6 minus root 6. Remember, there is a factor of 1 here, and it's kind of good if you can think about that. So 3 of these minus 1 of these is going to be equal to 2 of these. So that's my answer. That's what my answer should be. And to confirm it, I can use my CHS calculator, and I can go, what's the square root of 54 minus the square root of 6? I love that the calculator makes this easy. If this is difficult for you right now, you can definitely check your answer so you can get through these problems quickly using the CHS calculator. But you're looking for perfect factors in here, and when they're asking you to do this on a test or a problem, there's a very good chance that this is going to have a greatest common multiple like this. Now, what would happen if the square roots don't have a greatest common, divisor, a greatest common divisor? What would that be? Well, if there's no, that means I can't factor down to something that would be common in both of them, and then they'd be what we call not like terms. So I couldn't simplify it, I would just leave it as it is, okay? I might factor out, actually, I guess I might factor out something to get it a little bit more simplified. But let's put our answer in here. This is 2 root 6. See if I can see a few more of these to see if they all kind of look the same. Root 99 minus root 44. Oh my gosh. What would that be equal to? Well, I recognize that whenever I have two numbers in a row that are equal, that I could rewrite that. So I'm gonna do that. I'm gonna go in here and I'm gonna just show you how I can rewrite this. I'm pretty sure that you'll be able to see this one pretty quickly, right? So 99, that's equal to 9 times 11, which is square root of 9 times the square root of 11. And 44 is equal to the square root of 4 times 11, which is, equal to the square root of 4 times the square root of 11. And these guys are perfect squares right here and right there. So I can rewrite them as 3 root 11, right? Because the square root of 9 is 3. And minus 2 root 11. Okay? So I can rewrite this as 1 root 11. Right? Or just root 11. Right? And to double check that, of course, I want to double check because I want to get these right. I'm going to use my CHS calculator. Root 99 minus root 44. And here we go. Square root, that's control x squared down here. Square root of 99, go to the right, hit my minus sign, the square root of 44, and I hit enter and I get root 11, which is exactly what I thought it was. So I'm going to put a 1 there, root 11, and check my answer. Okay? Alright, so I see that root 11, and I think what is the greatest common divisor of all three of these, and I already know that 99 has 11 in it, right? And I'm thinking then roots 176 must have a greatest common divisor of 11 with this. But to be sure, I can go into my CHS calculator, and I can say, what is the greatest common divisor of 176 and 11? And just make sure that that's also the greatest common divisor 176 and 99. And I see that they both, everything divides by 11, right? So what happens when we take 176 and we divide it by 11? We get 16. So this is, 176 can be written as 16 times 11. And I already know this is 9 times 11. That's 1 times 11. So let's rewrite that. Here we go. And we're going to take this and rewrite it real quick. And I get, let's get another color in here. I'm going to write this as, let me make this a little bit bigger here. Okay, so I know that this is equal to 16 times 11, which is the square root of 16. Oh my gosh, how convenient. This is a perfect square. So that's 4 root 11 plus 1 root 11. I can rewrite that way. Minus, so how do we write this? This is 9 times 11, which is root 9 times root 11, which is 3 root 11. So I have 4 of this plus 1 more of this. That's 5 root 11, right? And I'm taking away 3 of the same thing, like terms, right? The radicals match, so I can just combine them. I say I have 5 of these, I'm taking away 3 of these, and I have 2 root 11 left over. Okay? And did I already do this in the calculator? I don't think I did. So let's try it again. And just so you can see, I want you to get the practice of seeing this. 176 plus the square root of 11 minus the square root of 99 equals 2 root 11. That's what we had written down. So we're going to put that in as our answer here, 2 root 11. And we'll do one more just to finish this out. I'm looking for the greatest common divisor of 54 and 96. So let's use my calculator and find the greatest common divisor of 54 and 96. And I see that they both can divide by 6. So 54 divided by 6 is going to give me 9. In other words, 6 times 9 is 54. And 96 divided by 6 is equal to 16. So I can rewrite these 54 as 9 times 6 and 96 as 16 times 6. So let's do that. And get a little picture here. Here we go. Last one I'm going to do here. So this is, oops, stretch that out just a little bit so you can see it a little better. And here we go. Get you another color. All right. So root 54 can again be written as root 9 times 6, which is root 9 times root 6, which is 3 root 6, right? 96 can be written as 12. Oh, Nope, sorry. Oh, maybe I can. No, I can't do it that way. Let me get my eraser out. That's just messy, so we'll just get rid of that. So 16 times 6, and that's equal to root 16 times root 6. And root 16 I know is a perfect square, so that's 4 root 6. So 3 root 6 plus 4 root 6 equals 7 root 6. And I'm not even going to check that in the calculator. I know that that's correct. So 7 root 6. And that's how that's done.